append with method is very similar to prepend with method, and we can reuse some of that code. But I do want to start by showing you how to put the node class in here. Some students just try to copy the node class from a previous project, and that can cause all sorts of issues. The easiest way is to go to the package here, make a new class, call it node. So now I have a node class. Go to the node class in a previous or another project, copy it, and then paste it into this one. That way you do it without causing yourself too much trouble. So back to append. A lot of this can be copied from prepend, so let's just hop over to prepend. I'm going to take the entire main here and copy it. And then I also need a print list. So the only thing I need now is to write this append method, because I start with an empty list 5 times. I'm going to get an integer, I'm going to append it, and then print my final list. So my prepend method has to be, my append method has to be written here. Public static, I'm going to return a node. It's going to be called append. It's going to have a node and an integer as parameter. This underscore here coming from NetBeans is because I haven't returned anything, and yet I've said I'm going to return something. So the easiest way to get rid of that is to say return, and now worry about this append. You will recall the algorithm for append. We have a list. The next of tail is null. We make ourselves a temp pointing to the node we want to append. We then make tails next point to temp. So we will say tail.next equals temp. And then we move tail on so that tail is now equal to temp. That moves tail on to here and no longer there. So now we have everything joined up with temp at the end, and temp's next is null, which is what we need because we always need the next of the last item in the list to be null. That's how we find or identify the end of our list. So this will work as long as we have a tail. But problem when we use methods is that we can only return one thing from the method, and the thing we return is the head. We cannot return the head and the tail. So even if we send the tail in as a parameter, if the tail alters, we cannot get that new value of tail. So I need to be able to find the tail in my list. So before I can do any of this code, I need to identify the tail. So I start out with tail. I can either use tail or current. I'm just going to choose now to use tail. I start out with tail pointing to head. So here's the code for that. Tail equals head. And now I need a while loop. While tails next is not null, move tail on. We've done this before with current. Whether you say current or tail. If you use current, then after this loop, you have to set tail equal to current. This way, I set tail to point to head, and then as long as tails next is not null, I'll move it on. Eventually, let's say I get to this one. Let's say tail is now pointing here. So when tail points here, tails next is not null. Move it on. So then tail now points here. Go back up. This is an entire loop. Go back up to the top of the loop. While tails next is not null. Well, tails next is null. So when I finish this loop, tail is pointing to the last item in my list. And then I can do this code. I may have to have a separate instance for when head is null. That is a special case. Other than that, does it work when head is just one item? Well, if I have just one item in this list, these don't erase very well. Let's just say they're not there. And let's imagine our list just has one item in it. Then what do we say here? Tail equals head. So tail is going to point to here. And then while tail.next is not null, but if there's only one item in my list, then tails next is null. And so I'm out of this loop, and tail is pointing to the same place as head, which is the only thing in the list. So if indeed we only have one node, this piece of code still works. It will not work if head is null, because this says tail equals head, so now tail and head are both null. And then while tails next, well, tail doesn't have a next if it's null. So this code will fail on this line here, which is why I have to deal with the empty list as something different. So let's see if I can copy this into NetBeans. And what was the other piece of code I needed? this guy over here. Okay, so we're reasonably sure that this will work as long as I've got a temp. So let me make myself a temp node. Temp is new node n. And we said that the empty list is a special case. So if head is null is my special case. What shall I do if head is null? Then I will just make this temp also the head. So head equals temp. Else. And all of this is done on the else. All right, let's read through this one more time. Temp is a new node. We're going to ask if our head is null, if we have an empty list. If we do, then head is temp and I'm done. Otherwise, I have to find the end of the list. When I come out of this is an entire loop here. When I come out of this loop, tail now points to end of list. And now I can set tails next to temp, and then tail is now temp, and my list is complete, and I'm going to return head. All right, let us see if this works. $10, $20, $30, $40, and $50. And there is my final list. Done. But it does make it a little bit more difficult because you cannot maintain the tail. You have to find it every time.